This video is all about radical expressions. So the first thing we want to know is, what is a radical? Well, when we're talking about a radical, we're talking about the symbol that looks like this. Now, if it's a square root, we're going to assume that this number that's in here is a 2. That's called the index. We don't have to write it if it's a 2, but a little number goes here. This part in here is called the radicand. So the symbol itself is called the radical, the inside is called the radicand, and the little number up in the crook is the index. So we might have something that looks like the cube root of 27. We might have the square root of 25. Notice that with the square root we don't have to put the number there because we're assuming it's a 2. So in general, what is a square root? Well, when we say what is the square root of 25, we're saying what number squared gives us 25. And in truth, there's 2 answers. 5 times 5 will give you 25, but also negative 5 times negative 5 will give you 25. In this case, I want the answer of 5. So when we say the square root of 25, we want what's called the principal or the positive square root, which is 5. If I wanted the minus, I would have to put the minus sign in front of the radical, like that. So here are some examples. And I put up here in the right-hand corner a list of perfect squares. So 1 squared all the way up to 20 squared. So when I say the square root of 25, we've just talked about this one. I want the positive or the principal square root. So I want 5. When I look at the square root of 9/64, we have a minus sign in front. It's kind of a little hard to see there. We can take the square root of 9 and the square root of 64 separately. So the square root of 9, if we look over here, not that one, not 9 squared. Square root of 9 is 3, and the square root of 64 is 8. So we get negative, which comes from this negative out in front, 3/8. It gets a little more difficult when we have variables in there. So when we have the square root of x to the 6th, we want to ask ourselves what multiplied by itself will give us x to the 6th, and the answer here is x cubed, because x cubed times x cubed, remember the rule is that we add the exponents, and we'll get x to the 6th. So one thing you can do is, if you think about what your index is, like a square root here, we can say how many times does 2 go into 6? And the answer is 3 times. This last one, the square root of negative 16, we're going to say that this is not a real number, because we know that when you multiply 2 things together, you're going to always get a positive. Either a negative times a negative will give you a positive, or a positive times a positive will give you a positive, but you won't ever get a negative underneath a square root. So then we ask the question, what is a cube root? Well, here we're saying what times itself 3 times. So if I'm taking the cube root of 27, I'm saying what multiplied by itself 3 times will give you 27. And if we look up here, 3 cubed is 27, so the cube root of 27 is 3. Interesting note, I could take the cube root of negative 27. That would be negative 3. Because when we're multiplying by something 3 times and it's negative, I can get a negative number. So when you're dealing with a square root, we can't take the square root of a negative, but we can take the cube root of a negative. Okay. So this one, very similar to the one we had previously, the cube root of x to the 18th. We can say, how many times does 3 go into 18? And the answer is 6. So x to the 6th is the cube root of x to the 18th. Can we take the cube root of negative 8? Well, if we look right here, we see that 2 cubed is 8. So when we take the cube root of negative 8, we should get negative 2. One other thing in this section is function notation. So keep in mind, function notation, the notation that mathematicians use, is used to make things easier for us. So let's take a look at an example. If we were talking about the cost to go to the movies. And we knew that one ticket was $9.50 per person. Then the cost to take a family to the movies would depend on the price per ticket. And we're going to let x equal the number of people that are going to the movies. So if I wanted to know how much it was going to cost, I might say that the cost was $9.50 times the number of people. But function notation would say, if I want to say that the cost depends on the x, we might say this, c of x. It's just a different way to write it that tells me that the cost, c, depends on x. Now I don't do anything on the left-hand side of this. Everything I do is going to be on the right-hand side. If I wanted to know the cost for 2 people, I would do $9.50 times 2, which would be $19. And that way, this notation right here says the cost to send 2 people to the movies is $19. Okay. The domain is all the numbers that make sense. In this case, you can't have a negative number of people going to the movies. You could have nobody going, but the domain here would be that x had to be greater than or equal to 0, and the range would actually be y greater than or equal to 0. Because it's either not going to cost us anything or it's going to cost us something else. Something positive. So let's take a look. If I wanted to find the domain from a graph or the domain from a function like we have up here. So we would read this f of x equals the square root of 2x plus 3. And what we know is that this radicand doesn't make any sense if it's negative. So we want 2x plus 3 to be greater than or equal to 0. And we can solve this inequality by first subtracting 3 and then dividing by 2. So the domain for this is x has to be greater than negative 3/2. If I want to do this from the graph, I probably need to get some ordered pairs here. 0, 1, 2, let's do negative 1. If I plug in 0, I get the square root of 0 plus 3. So I get the square root of 3, which is approximately, grab my calculator, 1.7. Squeeze that in there. If I plug in 1, I'll get the square root of 5, which is about 2.2. If I plug in 2, I'll get the square root of 7, which is 2.6. And if I plug in minus 1, I'll get the square root of 1, which is 1. So I'm going to try, it's kind of hard with my finger here, to put these functions, or these points, on the graph. So there is negative 1, 1, 0, 1.7, 1 and 2.2, and 2 and 2.6. You can see that I'm getting something that looks like this. We'll make that a little bit thicker. So my domain is all x values. So I'm looking at my x-axis here, and I'm saying, when do I start having values? And it turns out right here, this is x equals negative 3/2, and we're going to have x values from then on. So my domain is going to be negative 3/2 up to infinity. So let's use function notation on this slide to find function values if f of, for example, f of 2. Well, all we want to do here is plug 2 into the function. So 3 times 2 minus 1, this is going to give us the square root of 5. F of 4 means plug 4 in, 3 times 4 minus 1. So 12 minus 1 is 11. We get square root of 11. And the last one is f of negative 2. 3 times negative 2 minus 1 is the square root of negative 7. And this one here is not real. This one's not a real number. That concludes this slide. Have a terrific day.